Whoa.
So it's 1 and 4 because okay, I'm just like spreading out things.
Okay.
Oh genius. Okay, and then the antiderivative, the natural log is 1 over that thing.
Antiderivative?
Not the derivative.
Derivative, okay.
That's what I meant. Taking 1 fourth times 1 over 2x cubed plus 2x. And you have to take the derivative of the negative. So 6x squared plus 2. And then minus 1 over this. 2x times 2. Oh my. 2 times. Use here. Times 3. Okay. And then you combine it all. So this is going to be 6x squared plus 2 over 8x cubed plus 8x minus 6 3x over 2 Okay?
Hmm?
And then can we cancel either of this? Or no? So we're gonna cancel, and it's gonna be 3. So this, I don't wanna write it anymore, minus 3.
Good. Everybody follow? Any questions? Everybody got exactly that?
No, trying to like.
Questions?
Oh,
Well, or something equivalent to that, or, you know, that first line right there is great. If we left it that way, that'd be all right. Wouldn't be great to like use, and your multiple choice choices, possibilities are not gonna look like this. They're gonna look something more like this, maybe slightly different than that. Okay, they might get a common denominator and put them together that way. So no questions, everybody's good. We got there, or near there, equivalent to this, not near in that it's wrong, near in that it looks slightly different, but still correct. Okay. You can show us how this one's done. Kelly?
The first part of it.
First part.
I couldn't remember the.
Start it off for us then.
Then I couldn't remember if it was the ln and then the bottom part. What it was?
Yeah.
What else would it be?
Yes.
I couldn't remember if that was the rule.
That's the log rule.
Oh.
Good. Any questions about that?
I really wrong.
I took the derivative and moved down to 3.
I forgot about the absolute.
Yeah.
absolute value, that's pretty important. It's probably not going to really come back to bite you too much, except for in the free response, where your answer is the way you write the answer, and you don't put absolute value when the absolute value is necessary. Sometimes the absolute value is not necessary, like if you end up with the natural log of 2 to the x, or something like that. Well, 2 to the x is never going to be negative, so we don't have to worry about it. It's never going to be even 0, so we don't have to worry about it. So we could, if we had forgotten and put the natural log of 2 to the x like that, well, it's never going to be negative, so we don't have to worry about it. But yeah, you could lose points for something like that, and definitely you got to remember the plus c, because you lose points for that. So how do we?
Go back to my slide and have plus c, 'cause I forgot.
Well,
Yeah.
Oh, just kidding.
So how do we get from you see somebody do it? Oh yeah, that's how you do it. I forgot. Or oh, I made a mistake. And I'm not talking about a mistake like I forgot the absolute value or I forgot the plus c. That's just like remembering. So how do we get from the place of I didn't know how to do that, and oh yeah, I'm reminded now how to do that too. I don't need anybody to show me how to do it. I am able to do it myself. How do we get there?
Practice.
Questions.
Practice and questions, those sound good. Pretty standard things. Are you practicing and questioning?
Oh, are you asking us personally, like how are we gonna learn this stuff?
I'm just asking, if you tell me that clipping my fingernails will help you, I'll clip my fingernails more.
Ew,
than you.
that
If you
was
told me that
disgusting.
wearing different shoes,
No, purple tie.
wear some shoes. If the purple tie would magically bridge the gap, I would wear a purple tie. I'd get a haircut, whatever, pretty much whatever it took. You can't have any of my kids, and I won't hurt myself too bad. I'm really something. If it magically worked, and everybody would like just, I don't know, ask great questions, and we'd all work together, I would give some of this finger for the rest of my career. If I knew the secret, and I knew exactly what it was, and I could speak to you perfectly, I would give that. I would
That's
give
your
that.
sword fighting finger. You can't grip a sword very well if you don't have that finger.
Alright, I don't plan on doing any sword
Are you
fighting.
gonna fight for your wife?
Yeah. And your
With
children.
a bat with a nail.
He's giving that stuff
Right, well, if you think that the responsibility lies with you, then do what you can do. If you feel like there's something I can do, let me know. Okay? But practice is important.
Was there more work I was supposed to show on that?
Was there any work?
No, yeah.
But that is
Well,
the
I
one,
would change this to you,
No.
or some other thing other than x, because x being equal to stuff with x in it is kind of confusing.
Okay.
Otherwise, no.
It's like if I did that on the AP.
You throw a little. Oh, that'd be fine.
If I did that on the AP exam and I put the X instead of U, would I get in trouble for that?
You'd probably fail.
Hard to say. I doubt it.
No, automatic 0, I'd say.
Is there
I-
anything you can do that gives you an automatic 0 on an AP test?
0. I mean,
Just
if
like-
you do stuff wrong. Yeah, I mean.
If they just like look at it and they're like, no, this whole test is just dropping.
Oh, is 0 overall?
Yeah.
You have to like get everything wrong. You get a lot of stuff wrong to get it.
Drop it on the front
Simple.
of the test and not do anything.
It's not like the SATs where you get points for writing your name down or something. But I don't know. You have to try pretty hard to get to 0.
If you like drew something that's appropriate on the cover, would they still grade it, or is there anything that just makes them just like?
I don't know. I don't know what those policies are.
I'm just wondering.
I don't know.
Can I just go
Sophie wants to push the
outside?
limits on her
Show
AP test.
them the EPs.
First you want to draw this really inappropriate picture.
Alright.
Do all my questions right.
If we finish early, let's all draw it.
Yeah, I don't know. I mean, I think those kinds of questions are fun. What would they do? What would they do if this or that? It's a fun question to ask, but I don't know the answer to it. I don't know. Okay, who's gonna do this one for us?
Simon.
I had no good
shocked, that's why.
Oh.
Oh, shocks,
I
okay.
wear
Get
shocks
to
every
work.
day. Okay,
Wow, Connor really does look taller though, look at him.
Wow.
How tall are you?
Alright, good grief. Sorry about that.
Thoroughly embarrassed you now. There you
Spencer,
go.
how tall?
Alright, do some
Okay,
math, here we go.
I tried using
Ooh.
this for U and this for DU, but it doesn't work because that has a higher power.
Cool.
So we can do long division.
Ooh, don't mess it up.
Cute. That's too high. How can I select everything?
You get your, there you go, press select right there.
Oh, you already.
Oh.
You gotta grab the,
Oh, no.
You suck.
grab the little X with arrows on it. No.
Oh.
Okay, this one.
There we go. Alright,
Good job.
there we go.
Not impressed.
Get your pen
Draw
back.
it
Yeah,
again.
your pen back.
There we go. Alright, divide that by x squared minus 2x. This we can divide by x. X cubed minus 2x squared. Whole thing. 2x squared minus 4.
Yeah, I feel
Multiplied
like
by
I'm a shooter, that's what happens.
2. No.
You people look at that.
Oh. There we go. Multiply by 2.
It's going
Here,
down.
get that.
2x squared.
2x squared minus 4x. What?
Don't listen to them.
Okay. Give us 4x minus 4. We can't do anything with that, so it's remainder. Two x. Okay. We have to use f of b minus f of a for 3 and 1, so.
What?
You're subtracting 2x squared from 2x squared.
Huh?
Hmm?
We're gonna find the
Oh,
antiderivative.
okay.
Alright.
Oh, okay.
Connor, find the
Never mind.
antiderivative.
Fine.
That's what I'm trying to do. Plugging it in right now?
Trying to figure them out.
Have fun, definitely. We'll see if you're
Wow, alright, wow. That's serious.
We're just
So-
watching.
Today,
Okay,
you jerk.
plus 4 times 3,
Oh,
12,
man,
minus 1 would
Mr.
be 8,
Perfect.
over 3 squared, 9 minus 6, 3. B minus a, 1, so 1 plus 2 plus 0 over -1.
Okay. So I think what Simon's saying is, you're plugging in 3 and 1, right?
Yeah.
Into what?
Oh, yeah. The antiderivative.
Right, that's the same function, you've just
Yeah.
rewritten it in a different way, so you have to take the antiderivative now.
Okay.
Could have said it nicer times.
Okay.
Yeah,
There you
gosh.
go.
We'll see if you're right.
Everyone makes mistakes.
Nobody's perfect, alright? Okay, now I have to.
How do you write it?
Antiderivative. X squared.
We took the antiderivative of x, 1/2 x squared, antiderivative of 2 is 2x. What are you guys up to?
Kendra's on her phone. Sorry, that's all I know.
So you're working on taking the antiderivative of 4x minus 4 over x squared minus 2x?
Yeah. Two L. Do that. Yeah, there we go.
There you go.
Yeah. It'll be 2x. I'll use x squared minus 2. Minus 2 multiplied by 2, so that's.
Oh, it is not. That is a fun, cute thing. Isn't that neat? Just got
I'm doing that wrong?
No,
Well,
what is that?
Okay, it's
Let's
1/2
take a
minus
look
2.
here. Slightly. Okay, So, so u is x squared minus 2x, right?
You're trying.
Yeah.
And du is 2x minus 2,
Yeah.
right?
Yeah.
So, but what we have is 4x minus 4.
So we multiply that by
By 2.
No, you
By
divide it
1/2.
by 2.
Yeah,
So
we would multiply this by 1/2.
So
Yeah.
in front would be a 2.
So then we put a 2 out in front of it.
Oh, wow.
Let's go, you chums.
So it's really, really close.
Oh, there you go.
Just
Pro.
put
Junior board.
4 halves instead of.
Do you ever not have something?
I'm
Do we
sorry.
in this class?
Aren't you seeing this?
I have to do stuff.
No, she doesn't, she's
The
a
college
liar.
doesn't like it when you do stuff.
She's
Your
probably
colleges
going to
like
do
it
hard
when
drugs.
you show up to class.
She's going to do hard drugs.
Okay, you're right.
Have fun doing,
Then I can be careful free and literally.
have fun doing some lines in the bathroom.
Pretty crazy.
So Connor's now found the antiderivative of everything?
Yeah.
Woo.
Yeah? So if you were to, let me just really quickly jot this down, you're asking what about the plus c?
Yeah.
You can leave it, right? So you plug in 3 and you get whatever plus c. And you minus, you put in 1, you get whatever plus c. What's gonna happen to the c and the c?
We're gonna cancel out.
Cancel, so I don't really need to put it in there. If I do, it won't mess anything up. So when we're doing the FTC, fundamental theorem of calculus, we can kind of ignore the c, because it would get canceled out anyway. Goodbye.
Be careful under these.
I'll puke in your locker while you're gone.
You're disgusting.
So that's 3.
Yeah.
Oh, yeah, I feel like I'm really good.
I'm not quite sure how to do the actual log.
So you can just leave the natural log with whatever that number is inside.
Wait, you switched the.
So he's just plugging 3 in now and he's simplifying that part.
No, we switched there's x squared minus 2x above, and then you put.
Oh yeah, the plus.
I'm just full of mistakes today.
No.
But-
Kind's
You're doing great.
It's okay.
9, 6, 3.
Just gotta take a knee.
And it's 1, so 1 plus 2 plus 2 natural log. Negative 1.
Absolutely. Oh,
Man.
Ooh.
You did a good job. I did a bad job. By choosing 1, we wind up by having 1 as one of the limits. I have wound up with the natural log of negative 1.
What's the answer guy?
Oh, okay. Never mind. I did great. Go ahead.
I was thinking that low.
It's a big old trick question.
No, keep going. Keep going.
Oh,
You can do it.
okay.
We'll just clean it up a little bit.
Yeah.
Okay. Plus 2. So, minus 2. I can't just cancel these halves, right? No, there's no.
Is that a half over there?
I multiply.
That's 9
That's
halves.
9
It's
halves.
9 halves, yeah. So 9 halves, my total would be 8 halves.
Should be
Yeah.
8 halves.
Yeah, 4. There we go. That's 2 plus 4, let's see.
The column, you just need that. Saying go to the bathroom or something.
Do you need a garbage can?
I do
Myself puking, so-
read over negative 1.
I have never,
Three is
I've
after
never
values
made
should be
myself-
2 over 1.
Natural.
yes, I've made myself
three.
keep on.
Wow, you're losing quiz a lot. Oh my god, how did you go this far? You
Uh,
got it.
Wow.
Woo!
Nice. Good.
Best.
Good job. Okay, let's go back and just review. It's not any bad thing about Connor, but let's review Connor's mistakes. When he realized he had done something wrong, right? So where's somewhere he realized he had done something wrong?
Antiderivative.
When he,
Didn't take the antiderivative.
Okay, so didn't take the antiderivative, so remember to take the antiderivative after the long division.
Yeah.
Okay. Where else?
I was gonna say, like, for the very beginning, like, when he caught his mistake when he first did it, when he tried to do U and D, and it didn't work,
Yeah.
so instead he did the long division.
Yeah, I liked that you brought that up. So let's move this down
I'm not
here.
messing
Ooh, I almost had it. Let's see if I can catch on. Okay, so
U sub.
U sub didn't work.
When's that math competition?
Yeah, when is that?
26.
Next week of February?
Yeah.
Next week.
What?
Is this like the
Sunday, get a bus.
Today's
Okay.
the 19th.
26th, that next, exactly a week, next Wednesday.
Is there anybody who's not gonna be able to make it?
I don't know, hold on.
Are we Wednesday?
When's the next
It's
one?
like what?
We're missing, it would be
Wednesday.
this day. 'cause we
Next
don't-
week?
Yes.
Cool.
It would be 8 next week, Wednesday.
And what time do we meet?
Like right away.
Right away.
Yes.
6 in the morning.
No
No
idea.
English. No,
When do you come back?
That means we can make it for
Like halfway through the last year.
In your room. Get that.
That's all right.
Okay, so you tried U substitution, it didn't work. It needs to, you need to remember to take the antiderivative after long division. Doing long division, like when you do the long division, it's equivalent to what you had to start with, right?
Yeah.
And you need to remember to take the antiderivative of that. And anything else?
Oh, he, I don't know how to word it. The last part of the long division was like the remainder over that part of the use, when he was trying to take
Did 2 and 7 and a half.
Yeah.
yeah, that thing.
Okay, so
It was missed. Yeah.
Yeah.
we'll just say so here. Multiplied by 2 instead of 1/2. You gotta think, how am I gonna turn this into the du? And then like this little guy right here, that was, change it into a plus instead of a minus. Otherwise, that was really good.
Sorry.
Already applied.
The applause. Yeah, I'm just trying to be supportive. Yeah.
Isn't it just E3x3? Is that wrong?
Oh.
Well,
Oh, I
if
remember
it was
how-
e to the 3x times 3, is that what you're saying?
Isn't that the derivative? Yeah, I couldn't remember how to do the antiderivative. I remember
Oh.
how to do
Well.
the derivative. Would they not just be the same thing?
Not quite. If I wound up with e to the 3x, it means I took the derivative of something and got this. If I just started with e to the 3x, how would you take the derivative of this?
E to 3x.
e to the 3x
3.
times 3.
Oh.
Fun.
This isn't times 3. 1/3. So if we started with a 1/3 instead,
Yeah.
then then we get a 1/3 e to the 3x, and we multiply by 3, then 3's will cancel, and we'll wind up with just e to the 3x. Okay. Or if we let u be equal to 3x, and du is equal to 3dx, so we need a 3dx, so that this can be du, and this can be e to the u. And we need a 1/3 out here. So we got 1/3 times the antiderivative of e to the u du. Now that we have the same thing here, e to the u du, then the antiderivative of that is e to the u. So 1/3 e to the u, which is 2x, plus e.
Forgot about
If you're ever wondering if is this the antiderivative, take the derivative of it and see if you wind up with that. And if you don't, but you're close, then try and fix it. Maybe the constant multiple doesn't count. All right. Well. Now they're gonna make another attempt to take all the stuff that we're supposed to know and put it together. Okay, so I just grabbed some sample AP questions that, what is this whining and whimpering and huffing and puffing?
Yeah,
I said okay.
yeah.
You were happy?
Yeah.
Yeah.
Hope I don't ever throw you a surprise party. Just go. Okay. All right, so I've just put them all on this here, and printed them out, and here we go. And what I want, circled a few that I want us to start out with, because they're kind of more current than the rest. So 1, 2, 4, 5. And then there's not that many after that. I just want to get started with those. So 80 and that. And 90. When you're taking the AP test, it'll go 1 through 20. Pretty sure it goes 1 through 28, and then it jumps to 70. I think it is 76. Okay, so it's weird. I think I've never taken the AP test. I think if you ask somebody who has taken it, it's probably because you're filling out a Scantron, and then they want to start you out on like some other part of the Scantron, maybe. So they jump down to that number. That's my guess.
So, how high on math did you go in high school?
Like pre-calc,
Pre-calc?
something like that. It was called math analysis. I don't know.
Math analysis.
Name these things these weird names, but yeah, it was some trig and stuff.
Okay.
I was on course to take calculus, but in 8th grade I had to go back to pre-algebra because we missed so much school because we moved. So
Yeah. Dang it, parents.
Where you're at now, though?
it's the Navy's fault.
Did you move every 3 years?
We moved like every year for a while. Sometimes we lived somewhere for just 6 months.
Oh, airport is always every 3 years.
Yeah, we were like every 1, 1.5, or 2.
Yeah, so we're always.
We never stayed anywhere for 3. That's too long.
Yeah, for us it was every 3 years, then it's not 3.
Alright, we'll pull 4 to the side here. So it is challenging. The most challenging thing is that there's all these ways to take antiderivatives. There's fewer than you think, but there's a few. There's more than 2, and then you got to figure out which way you're supposed to do it.
Yeah.
Right? So let's see. We know how to take the antiderivative of like sine and cosine, but that's not just sine and cosine. We can't separate them because they're multiplied instead of added or subtracted.
Yeah.
So if it's not one of those basic ones, then we're working our way into U substitution. If it's not just really obvious, then probably U substitution is what you should do. Probably. To do U substitution, we've got to see it as, we've got to make it look like some function times the derivative of that function. Right? Or maybe it might make more sense to think of it as f of x times f prime of x. Okay? So, does any part of this look like? Does it look like there's a function and then multiplied by that function is the derivative of that function? Does it look like anything like that? So what function do you see? And then what's the derivative that's being multiplied by it? True sine cosine?
Isn't it
Cosine.
Isn't it just
Square.
cosine of x squared?
So so as I'm gonna drop these limits and we're just gonna work on the antiderivative, it's important to remember that cosine squared of x means cosine of x and square it. That's what that square there means. What's that?
Derivative of cosine is sine.
The derivative of cosine is almost sine, negative sine. So if we put a negative in front of there, then we have a function inside the square function times its own derivative. And we just threw that negative in there, so we're going to have to put a negative in front. So now this looks like, if we replace this with u, we got u squared. Is this exactly right? Is this exactly the derivative of the cosine? Yeah? So this would be du. What's the antiderivative of u squared du?
2u.
True, that is the derivative, it's the antiderivative.
Oh.
2u.
The antiderivative.
Oh.
1/3 u.
Yeah, whoops.
1/3 u cubed plus c. We're going to use the fundamental theorem of calculus, so we can kind of ignore the c. We got negative 1/3 times u, which is u cosine of x to the third power. And we're going to plug in pi over 2, plug in 0, and we're going to subtract. So we got negative 1/3 times the cosine of pi over 2. We're going to cube that. Minus a negative 1/3, so plus 1/3 times the cosine of 0 cubed. And plus c, I don't know what I'm doing there.
Oh, so that was actually really easy.
So it's the cosine of pi over 2. It is time. The time has come for you to know your basic trig facts. Okay?
0.
Huh?
0.
0, the cosine of pi over 2 is 0. So 0 to the third is 0 times negative 1/3 is 0, so this is 0. Plus 1/3. What's the cosine of 0? 1. 1 cubed is 1 times 1/3 is 1/3. So 1/3. That's the hardest part of that one.
No one can functions.
That's the hardest part. Knowing your trig functions. Okay, so maybe you're gonna review your trig functions. You're gonna go through and memorize your sines, cosines. Really, sines and cosines. If you know your sines and cosines, you know your cosecants, your secants, your tangents, your cotangents. For pi over 0, pi over 6, pi over 4, pi over 3, pi over 2, and then all the way around those angles around the unit circle.
So when I was for Frank's problem, I put sine of x times 1 over secant squared of x, because there is a derivative of secant squared.
Is sine of x over
No.
sine of
Well,
x?
it could be sine of x over secant squared.
Okay.
Yeah, is that even possible, or was I just going and?
Well, if you made it the sine of x over secant squared x, okay, yeah. Well, it might work, but now we have this fraction. Fractions, typically, if you have a function over a function, you're going to want to use the log rule, right? So you're going to hope that this is a function and this is the derivative of that function. It's not. What is the antiderivative of, or what's the derivative of, antiderivative of secant squared is tangent.
Yeah.
Yeah, and that's not working either. So, it's a good idea. I mean, if we were in another situation, that may be the way to go. We may want to turn it into a fraction and use the log rule.
The derivative of secant to secant tangent, right? Or,
Yep. Derivative of secant to secant tangents. The antiderivative of secant tangent to secant. All right. After 4, what was the next hardest one?
80 or 90.
80 or 90?
280.
This one 80?
This one's 80.
Okay, so the graph above displays v of t for a moving object. What is the total distance traveled by the object during the time interval? Okay, so I'm going to cut right to the chase, tell you the shortcut, which may not sound like a shortcut. I could explain this whole thing in terms of everything that we know up until this point, but I'll say instead of that, v of t. What's really going to serve us well is to remember that there's this connection between the velocity function, the acceleration function, the distance function, or position function. Distance and position commonly referred to almost synonymously. Okay? So what would be the acceleration function? How would we get the acceleration function if we had the velocity function? Take the derivative of the velocity function, right? So it's just v prime. It doesn't ask anything about the acceleration, right? That's probably not that helpful. Okay. But what about the position function? The antiderivative of v, right? The derivative of the position is the velocity, so to go the other way, the antiderivative of v is s. Okay? The antiderivative of v of t gives us the position. All right, so I want to take the antiderivative of the velocity function to find the position function, right? So, well, if I were to do that, I would want to find the total distance from, that it traveled from here to there, right? So I want to find the antiderivative from, what's that? From 0 to 12, okay, from 0 to 12. So not to 15, to 12. Well, now, this is a crazy function. It's a piecewise function that I'd have to write several different functions and take the antiderivative. Do you think that's going to take all the time to do that?
No.
If I were to find the antiderivative, what does that have to do with the graph? When I find the antiderivative, the definite integral, what is the connection between the definite integral and the graph? It's the function. This comes from when we were first learning about antiderivatives in the fundamental theorem of calculus. If we take this guy from A to B, say this is f of x, and I find from A to B the area of the curve, right? That's what it was all built upon. So if we go back here, I want to find the antiderivative, because the antiderivative would take me back to the position, right? If I found the antiderivative of the velocity, I would have the position function. And if I want to know the total distance traveled, I would almost do this. I would almost do this thing right here. I'll tell you why it's slightly different. It's just the choice of words that they use. Okay? They don't say displacement, they say distance. Okay? Let's forget about that for a second. For right now, let's find the area under each piece of this curve. Okay? What's the area under this block? 0. The area is 0?
Wait,
That's part of the line right there.
oh, hey, it's,
Yeah.
16.
Oh, sorry, that's slightly darker. That is the function right there. It is 16. So 16. And the area underneath here? 8. So we got 1/2 base times height. Right? We took a block,
Oh, look at that.
a square like that, and half that. That'd be 8. How much is this area?
-8.
-8. Good. -8. Underneath that block. So. All right. So let's talk about this real quick. Sorry, that's not the right triangle to do. It should be -8.
Yeah,
okay, I was
Here.
confused.
Thank you for not pointing. I caught it.
So if we were to actually take the definite integral from 0 to 12, what would it be? It would just be 16 to 8, and the negative 8 would cancel each other out. Okay? Here's what's happening. This thing is moving at like 4 meters a second for 4 seconds. Right? So it went 16 meters. Right? That is its velocity is 4 for a duration of 4 time units. So it's gone 16. But that's what we learned when we did our experiment. I had you drive for 20 minutes and record your speeds. Right? It would round be the area under the curve, under the graph that we made. Told us the distance that you traveled, or should have been pretty close. Right? So the area under the curve is 16 for that, and then over this time interval, well, the velocity is changing. This person is slowing down and stopping, or particles, or whatever. But it still goes 8, right? And then it goes 8 in the opposite direction. Okay, so it went 16, went another 8, and then it came back another 8, so it went a total of 16. But if we count it up that way, that's what we would call displacement. And where did you end compared to where you started? You ended 16 away from where you started. What was your total distance? That's how far you moved. Forwards, backwards, it doesn't matter. So what's the total distance? 32. So we went 16, we went another 8. We went another 8, it was in the opposite direction, but when we say distance, distance is the whole thing. What is your trigonometer read? Right? So there it is. We have traveled a total distance of 32. So here's a pretty key thing. You're going to get lots of questions about particles moving, and you're going to get graphs, or they're going to give you equations, or whatever. And then they're just wanting your brain to quickly make this connection between, velocity. Does it ask me about acceleration? I'll take the derivative of the velocity. It gives me acceleration, and then it wants me to know something about position, so I'll take the antiderivative again. Or given velocity, and they want to know something about the distance, the displacement, so I will take the antiderivative of the velocity to get the distance function, right? We quickly want to make these connections between functions, their derivatives, their antiderivatives, and the connection that those make to the graph.
So if it wanted the displacement, then it'd be 16, right?
Yes.
Okay.
So displacement, where you stopped, how far away you are from where you started, that's displacement.
Okay.
So yeah, displacement, I could run all over the place for 100 years, but if I started here and I ended here, my displacement would be 0. I could go anywhere.
Okay. But then distance would be everything.
Yeah, everything that you did, front, back, side to side.
Okay.
All right, so then we'll do 90, I guess. There's 90. Now, technically, this is like a chapter 6. Oh, I meant to give you 92 as well. Whoops. But 90 is good. Okay.
Oh, we do 92.
Yeah, we'll do 92 in just a second. All right, so let me show you kind of the long way and then remind you of something called the second fundamental theorem of calculus. Okay, the fundamental theorem of calculus, we use it all the time. The second one, we don't use that often. Okay? So, here's g of x. It's this definite integral of some function. Okay? Notice it goes from 0 to something, to x. Well, like, that's the value that you would plug into x. So you would take the definite integral from 0 to whatever x value you plug in, right? And that x value would be the one that gets plugged in for t. Does that make sense?
Yeah.
Once you take the antiderivative, yeah. Okay. So then it asks us about something about g of x. It asks us about local minimum of g of x. Okay, so let's just say I have this function g of x, and I want to know about its maximum and minimum values. What do I do with g of x to find that out? Find the derivative of that thing instead of equal to 0. Okay, so if I wanted to take the derivative of g, well, first I kind of need to have g, right, in maybe a more manageable way, form, whatever. So now I've got to, to find g, I've got to take the antiderivative of that in terms of t, and then I need to use the fundamental theorem of calculus to plug in x and then 0 and subtract, right? Okay. So this is going to be kind of the long way around, and then I'm going to show you the fundamental theorem of calculus calculus, and if you can spot it, when you're supposed to use it, it'll just save you some time. So we'll take the antiderivative of this first. What's the antiderivative of t squared minus 3t?
1/3 2t
Minus, I said 3/2 t squared.
Everybody agree? 3/2 t squared?
Yeah.
Okay,
Minus 4.
minus 4t
T.
plus c. But then we're going to use the fundamental theorem of calculus, so we're just going to plug some stuff in, right? So we're going to plug in b, that's x. 1/3 x cubed minus 3 halves x squared minus 4x. See how all the t's are just got replaced with x's. Okay, so that's the b, that's f of b. We're going to subtract f of a. So we got 0 squared, or sorry, 1/3 times 0 to the third minus 3 halves times 0 squared minus 4 times 0. Well, that all comes out to be 0. That's convenient. All right, well, then we're going to take the derivative of this, right? Because this is now, this is actually g of x. We're going to take the derivative of g of x.
So then it just turned out to be the same thing. with
Yeah, we just
x.
found this by saying, what when I take this derivative, I need to wind up with that. Well, I'll take the derivative, I should wind up with that. So g prime is exactly like this function, just with x's in it. Okay? X squared minus 3x minus 4. So that's g prime of x. And then we need to do something with it. Okay? But notice this. Even if this value weren't 0, if it were any number, then g prime of x would always come out to be this. Just that with x's in it. Okay, so here's why. Imagine this wasn't 0, it was 5. Okay, well then, how would this look different? Well, this would have a bunch of 5s in it, and we'd find, like, we crunch all these numbers and we come up with some number, right?
Yeah.
Some number. But what did we do right after? We took the derivative, so I'm going to take the derivative of this, and I'm going to get this, and I'm going to take the derivative of this. What do I get when I take the derivative of this? 0, because it's a constant. Okay? So we've just come upon the second fundamental theorem of calculus. It says this. If you're going to take the derivative of something that's defined by the definite integral from any constant to x, to some x value, of f of t dt, well, then I'm going to take the antiderivative, then I'm going to put x in, I'm going to put a, and I'm going to take the derivative of that. That's just going to cancel out the a part of it. So I'm just going to wind up with f of t, but with x's instead of t's. Right? It's f of x.
Okay.
With no plus c. Right? Because it's a definite integral, so we don't have a plus c. We did the fundamental theorem of calculus, and the c's canceled out. So that's the second fundamental theorem of calculus. Take notice of when one of the limits of integration is x, and your function is in terms of some other variable, probably t. All right? So we just wound up with that x squared minus 3x minus 4. Okay, we found g prime. If we use the second fundamental theorem of calculus, we would have done it really quickly. Just jump down to what that is. Okay. Then what do we do with it? Set it equal to 0. X squared minus 3x minus 4 equals 0. X what? Yeah, that's right. And so at x equals -1 and x equals 4, these are the two places where we have what? Zeros for the slope, right? But we have to find the minimum. Okay, do the second derivative test. That would be fine. Take the second derivative, see if it's concave up or concave down. Also, this is the derivative of a cubic function, right? A cubic function with a positive leading coefficient. So keep in mind that a cubic function with a leading coefficient that's positive will always go like this. Right? So you're going to have a maximum here and a minimum here. So your minimum will be on the right side. So which one of these is going to be where your minimum is?
No, 4.
No, 4. 4 is going to be where your minimum is. All right. And if the question was asking, you know, what's the y value, you could plug 4 into your original function. Right here, that's what it's asking for.
Is that the original function?
The original function is g. It's asking what the minimum of g is, right? Oh, but it was asking at x equals, and so we just say 4. Let me take this. I wanted to do this one real quick. Now, like I was starting to say, this is technically like a chapter 6 question about differential equations. But we've talked about slope fields before. Slope fields just show you the slope of some function, okay? Well, the slope is the derivative, right? So this is saying that the derivative of some function is given by x squared over y, right? Or the derivative of some function is given by y over x, or x times y, or negative x over y, or negative y over x, right? Which of these derivatives is going to give you these slopes at these x comma y's? See what I'm saying? All right, so here's one, like a giveaway. What are all these slopes?
Zero.
Okay, so we get a 0 slope when,
X is 0.
when what?
Y.
When x equals 0. Okay, when x equals 0. That puts this one out, right? It's undefined when x is 0. And we can eliminate that one.
And the
Yeah, not that one. So we're down to these 3,
Yeah.
right? Then we come over here, we have these vertical slopes. What kind of a slope is a vertical slope?
Undefined.
It's an undefined slope. So it's an undefined slope when
Y.
y is 0. So it's not this one.
Wait, why isn't it that one?
Well, our slopes when y is 0, they're undefined. But if this gave us the slope of some function, and when x is 0, we'd have a slope of 0, and when y was 0, we'd have a slope of 0. To get an undefined slope, we would have to divide by 0. So it's one of those. And then we can go to like, I don't know, this guy right here. This looks like it might be a slope of 1 or something like that. So let's plug in that value. It looks like a negative 1, 2, right? And see if that's the kind of slope we get. Or we could say, let's see, we get all of these slopes. What kind of slopes are all these?
Negative.
Negative and these ones? Negative and these ones? Positive and positive?
That's like.
So notice that when x is positive and y is positive, our slopes are negative. Right? Is that going to happen here? X is positive, y is positive, we get negative slopes? No.
G,
It's
the
gonna be
G.
negative. You just got to remember that the slope field is just telling me what the slopes are at any x comma y. How does it do that? Well, the derivative, basically, that's what this is given by that guy right there. So at any x comma y, we plug in that x and that y, and it tells us the slope at that point. The only way we're going to get undefined slopes with y is 0, and 0 slopes when x is 0, and negative slopes in the first quadrant would be with this guy. That's the only one that meets all the criteria. We didn't even really have to try that hard. We didn't have to plug anything in specific. It's the only one that works. Okay, after 92, which I didn't give you, what was the hardest one? 5 after that? Is this 5? Which one is this?
No.
No, that's 7.
Might be on that.
Did you plug 0 in for? Oh.
Maybe we need some more room. Alright, so f prime is given, or f is given by this. We want to find f prime of 0. So before we can find f prime of 0, we should find prime, of course. So f prime, alright, is the derivative of the outside. And the outside function is the natural log, so derivative 1 over all that stuff.
Yeah. What's the derivative of the
Then the derivative of the inside.
1 1 plus
Derivative,
Nothing.
0 plus
1
1 plus
5
e to the 5t
times 5.
times 5, because we gotta take the
Yeah.
derivative of the inside function. The derivative of 5t is just 5. That's it, there's nothing inside of that function.
Yeah.
So f prime of 0, we need to put 0 in here. 1 over 1 plus 0 plus e to the 0 times 1 plus e to the 0 times 5. Okay, so that's 1 over, what's e to the 0? 1 plus 0 plus 1 is 1 plus 1, 1/2. We got 1 plus, what's e to the 0? 5. 5. So 6 over 2. 3. The ones that are numbered, let's say lower than 70 in this packet, would be ones you would be expected not to use your calculator. Did you use your calculator?
Not
I didn't.
Yeah, I don't know what 1 plus 1 is.
So they work out fairly nicely. And we'll show you how to use your calculators to help you speed things up. If you need to find like the area under a curve or the slope of some tangent at some point. But until then, we're going to concentrate on
Old fashioned.
understanding that, yeah, the old-fashioned way, the concept. And you know what, it's not even that old-fashioned. The really old-fashioned way would be using the limit definitions, find the derivative and the antiderivative. Or not the antiderivative, but the definite integral. Okay, in 4 minutes, what's the next one?
Oh my.
Number 1.
You can do it.
Yeah.
You can do it.
So it's asking for dy dx, what does that mean? The derivative of this. What do we need to use to take the derivative of this? Change. So 3 times 3x squared minus 1 squared times,
6x. There we go.
so 18x times
Oh,
3x.
very good. Go this far.
That was
Squared.
pretty.
This comes.
Kind of like a 5-second rule. Get gross.
Preview number 2.
Preview number 2, yeah, we can do that.
Oh, what's the definite integral?
Or we just go through.
Okay, so if we're going to take the antiderivative of x e to the negative 2x squared dx, I'm thinking,
Do we have to with the x in front like that?
the product rule would be if we're taking the derivative, we're taking the
You
antiderivative.
gotta do like
Oh my
negative
god.
You gotta do like negative 4?
4. Yeah. Use
Okay, so if you use substitution and u is
Yeah.
what?
negative 2x squared.
du equals negative 4x dx. So we get x dx, so yeah, we need that negative 4 and a negative 1/4 out in front. Negative 1/4 times, this is just e to the u, du, well this is du, right?
Yeah.
So what would the antiderivative of that be then? The e to the u, which is 2x squared.
Ah.
We're going to take that from 0 to 3.
Oh.
It's negative 1/4 times e to the negative 2 times 3 squared minus e to the negative 2 times 0 squared. So we get, move this down a little bit. So e to the negative 18, right? Minus 1. So there's that. And then there'll be this is the multiple choice section, so there'll be some multiple choice that is some form of that. To be able to work with that.